Okay, guys, welcome back. We're just going to summarize this for a second, and I know I just finished, talking about these four formulas and teaching them to you, and then telling you that this is how you're going to do it for the next, bunch of weeks here, guys. But I'm going to tell you right now, guys, that I don't use those formulas, okay, or I don't think about them at all. All right, now. Why did I talk about them? Well, because they are the formulas that are going to end up being used. But it's not, I don't try to remember them because it's going to be confusing, okay? Because when you're doing your three-phase circuits, you got to go like, okay, is this Y or delta? Is it the phase voltage? Is it the Y voltage? I don't do that, okay? What I do is I actually look at the diagram and try to decide what's going on. So what I'm talking about here is, let's say I was given the line voltage and I'm asking you about the phase voltage, okay? So the line voltage, let's say, I don't know, it's 1,000 volts, okay? And my question is, what's the phase voltage? Well, I could go, okay, this is Y, and then, try to remember the Y formula, and then transpose it, and then, calculate it. But I don't do that. What I do is I look at the circuit, okay? So let's say this was 1,000 volts. This is E line, guys, from here to here, okay? Now, the question is, what is E phase, okay? Now, I could transpose that formula, I guess, if I wanted to, but what I do instead is I look at it. If I have a voltage of 1,000 from here to here, what's my voltage going to be from here to here, from there to there? Now, the options are, it's going to be more than 1,000, less than 1,000, or equal to 1,000. Okay, because that's sort of what all your calculations are, right? You're going to have times root 3, which means it's going to be more, divided by root 3, it's going to make it less, equal to, because some of these formulas are equal to. If I apply all the things that I know about electricity and about series circuits, okay, if I have 1,000 here, is that going to be more than 1,000 or less than 1,000? The answer is going to be less, because it's going to be this voltage plus this voltage is going to equal that. Now, it's not going to be 500, but I know it's going to be less than 1,000, which means I'm going to divide this by root 3 to get a number that's smaller. So I'm just going to go like this. E phase, it's going to be 1,000 divided by root 3. Because if I take 1,000 and divide it by root 3, I'll end up with a number that's less, okay? So 1,000 divided by root 3 equals, whoops, I messed that up, 1,000 divided by root 3. Okay, it's 577.4 volts. Okay, guys? Same with this one. Let's say I gave you a voltage here. E phase is equal to 90 volts, and you're looking for E line. Now, I could try to remember the formulas, try to figure it out, okay? But what I'm going to do instead is just look at this, okay, guys? And if I take my voltmeter and measure 90 here, from there to there, what's going to happen if I measure it here? And you can see that it's the same, I'm measuring in the same spot, basically. There's nothing but wire between, this 90 volts and whatever voltage this is. So my question is going to be, every single time, is it more, less, or equal to? And my conclusion is it's equal to, okay? It's going to be 90 volts. All right, guys? So let's say, different example, okay? Forget about these numbers. Let's say this phase voltage was 60 volts. Okay, let's do it. Let's turn this over. Okay, so I'm going to draw a real quick Y here, okay? Let's just do a couple, okay, guys? Okay, so E phase equals 60 volts, okay? Question is, what is E line? So I'm measuring here 60. What if I measure here? Is it going to be more, less than, or equal to 60? It's going to be more, because I'm going to have that 60 plus that 60. But it's not going to be 60 times 2. It's going to be 60 times root 3. All right, so it's 103.9 volts. All right, guys? Same with this one. Let's do a delta again. Okay. E line equals 750 volts. E phase equals what? Well, I'm measuring here with my voltmeter. All right, guys? What happens if I move my meter over here? Is it more, less, or equal to 60? The answer is equal, so it's 750 volts also. All right, guys. Now, let's try that with current for a second. I know I'm going fast, guys. Let's say, forget about the formulas, okay? I line is equal to 99 amps, okay? Question, I phase, is it equal to more, less than, or equal to 99? Well, I'm going to cover these up. If I've got 99 there, you know, what do I have there? It's going to be 99, okay? It's going to be equal because I know that in series circuits you only have one current. Let's say I have a current here of 31 amps, okay? That is I line. I phase, guys, equals what? Well, here's my phase current. I've clamped on over here. What if I clamp on over here? Is it going to be more, less than, or equal to 31? And the answer is less than, because that 31 is going to get fed from here and here. That means I phase is going to be 31 divided by root 3. All right, guys? So, because if I divide it, I'll get a number that's less, okay? 31 divided by root 3 equals 17 amps, okay? 17.89 amps. 17 there, adding up to 31. All right, guys, now let's try that out over here again. Different example. Let's say my current here was, hold on. This is I phase, okay, guys, and it is 16 amps. I line. What do you guys think? More, less than, or equal to 16. Okay, equal, okay? It's all the same wire, right? So this is just going to be 16 amps. Same with over here. Let's say this is I phase. It is equal to, I don't know, 20 amps, okay? Now, I'm asking you about I line, okay? So I'm looking at it. More, less than, or equal to 20. Okay, I got that, 20 there, coming out here. That means it is multiplied by root 3 to get a bigger number. 20 times root 3 equals, okay, 34 amps. All right, guys, so that is the method that I use to try to figure out what's going on, rather than try to, you know, memorize a bunch of formulas and then pick the right one and then transpose it and then figure it out. Okay, what I do is I look at the circuit and apply, you know, everything that I know about circuits to it. All right, guys. Now, there is one thing that happens to students with that method that messes them up, and that is this. Well, I'll start with a brand new one here, okay? It's just so you guys can see it. But let's say I had a Y system. Okay, so here's my Y connected system. And E phase was, I don't know, 290 volts. Doesn't matter, right, guys? And I line here, 17 amps. Okay, but we'll start with the voltage here. Okay, so 290 there, right? 290 here. 290 here. And so what students will do is they go like, oh, okay, I got 290 on that wire. So, you know, what's the voltage on this wire? And then they say, well, that must also be 290 because they are connected together, okay? And that's not how electricity works, guys, because there isn't 290 volts on that wire, okay? The phase voltage is 290, but that wire is not 290, okay? Because when you're measuring voltage, there's two leads on your voltmeter, okay? And when you're moving from phase to line, you're actually moving the leads, okay? From here, that's your phase voltage, right? To here, there's your line voltage. And so the 290 that you see here is from there to there, right? And that wire is 290 from there to there. But when you're measuring the line voltage, guys, you're moving your meter leads, one of them at least, right? Now you're moving it to there, E line. So imagine yourself measuring that voltage, okay? Because literally I get people saying E line is 290, and they say it is because it's connected to the phase, and the phase is 290, all right? So that line must be 290. But that line is nothing, okay? That line is 290 from here to somewhere else, to here. And it's that 290 plus that 290, so this will be 290 times root 3, okay? Whatever that is, 290 times root 3, 503. Okay, guys? Because, okay? Now, that does work with current, though, right? Because if that line current is 17 amps, guys, that is in that wire, okay? A voltage is not in a wire, it's across wires or across points, but current is actually in a wire. In fact, I'm going to put my clamp-on meter there, okay? And I can literally move it and slide it down to here, and you'll see that that current is also 17 amps, right? That's I phase, okay? So that works with current, but it does not work with voltage, okay? Voltage is a two-line thing, okay? It's a potential difference across two different points. And imagine yourself moving the meter around, okay? I'm measuring here. Now I'm measuring here. What is the voltage? I'm clamped on here. Now I'm going to clamp on there. What is the current, okay? And if you imagine yourself doing that, you can get the answers correct, every time. And by the way, guys, you do need to get the answers correct every time, okay? Because we're going to be doing three-phase for a long time. And every single three-phase circuit question, problem, starts with figuring out what all the voltages and currents are. All right, guys? So stick around for one more video. I'm sorry that this is a long one, okay, guys? And then I'll assign some homework.